Let us try to understand line balancing with an example. Suppose there is a company manufacturing a particular product. The customer demand for the product is 160 units per day and total working hours per day is 8 hours. The product is manufactured by a sequence of operations on three machines. That means machine A makes 20 pieces per hour, B makes 10 pieces, machine C makes 5 pieces. So our demand is 160 units per day. Okay, and the total working hours is 8 hours. That means we need to manufacture 160 by 8, that is 20 pieces per hour. So that is our requirement. And you can see that the machine A makes 20 pieces. That means the sequence of operation is like this, from machine A to B to C. Okay, so the machine A makes 20 pieces, that is in line with the our demand. Okay, but the machine B makes only 10 pieces per hour, machine C makes 5 pieces. So that means even if I make 20 pieces per hour, B can make only 10 and C can make only 5. Ultimately, we will get only 5 pieces per hour. Okay, which is not in match with our demand, that is 20 pieces per hour, right? So what we can do here is to install one more machine, that is B, and make this a workstation. And also in the case of C, we will install 4 machines C, okay, and make this a workstation. If you make it like this, then this can produce 20 pieces and this can also produce 20 pieces, and finally you will get our required production rate. So this is what you mean by line balancing. That means earlier we had a line, this was highly unbalanced. That means one workstation produced more than the other. Now we are balancing the various stations. That means each station produced the same number of work pieces. Okay, so this is one example of line balancing. Now let us look at the various definitions of line balancing. Okay, so line balancing is to match. So we have seen the production rate to takt time. So what do you mean by takt time? Takt time is the available production time by the customer demand. Okay, that means so our production time may be 8 hours and the customer demand may be 160. Okay, that means so that is 8 by 60 or 1 by 20, or if you find it in time, that means there are 3 minutes to make a piece. You have only 3 minutes to make a piece. This is an example. And you can see that there are several workstations like A, B, C. Okay, that means each workstation should take only 3 minutes. Then only we can match the demand to the production rate. Okay, and this is called the cycle time. Okay, cycle time, that means the time taken by the workstations, okay, for the process. Okay, it can be 3, it can be 2, 1, etc. That means a balanced line means no workstation is overburnt and variation is soothed. That means so if you have several workstation and one takes 5 minutes and this takes 1 minute, that means, and this takes 2 minutes, you can find a lot of variation in this among the workstation. So you can prevent this. So that means if you can make this 4 minutes, so that means you can reduce the variation. And we will try to reduce the waiting time. So that means if A takes 3 minutes and this takes 6 minutes, that means there is a lot of waiting time for the product. Okay, this is called line balancing. So we will look at some of the terminologies here. So takt time is defined as the workable production hours divided by the units required or the customer demand. For example, workable, usually the production hours is 8 hours, and let the work demand be 200 units or 160 units. So you can find the takt time. And then cycle time is the net production time by the number of units produced. For example, the net time, let it be 8 hours, and we are producing only 120 units. That is called the cycle time. Okay, so our aim in line balancing is to make this equal, cycle time and takt time. And another terminology is the lead time, that is the time taken for the delivery minus time at which you are ordering it. So that's the lead time taken for an order to be delivered.